Hello guys, I hope that you will be really very fine this day. Today in this video I'm just gonna make you learn how to make a vending machine and how to make a simple garage door opener with the help of this table that is showing here. This is a state diagram, and this is the melee machine. This video is consisted of the three parts, and the third part here is to make a simple sequential circuit in order to have a know-how about the how does it works properly. Don't waste your time, and let's start the video. This is the first part of this video, in which I have just make a sequential circuit with the help of combination circuit, and then after that I have used the logic analyzer at the output. Here we will go. First we will see that what the question is saying. It's saying that derive the state diagram of the following circuit and simulating the purchase, and use the logic analyzer to monitor the output. You can add only 1 hertz of the clock from the source generator. So this is the circuit that we have to implement. First we will go towards its table that is just like that. Here you will see that I'm just going towards the customer for, I'm sorry, it's taking a little bit time. Here is the block diagram of that sequential circuit. Means that there is a combination circuit behind the sequential circuit, and there is the output. After that we can see that the total number of the states are 5. Means that the states that are completing the entire circle or making an entire cycle are 5. So the number that covers the 5 is 8 in the power of 2. So the total number of the states will be the nth power. So the total number of the states bit will be 3. After that we can see here the state table of the following diagram, following circuit in which there is a present state A, B, C, and A plus B plus C plus, you can also say as asterisk, and these are the next state in which we will provide the input, and then the output of that then the circuit goes towards the next state using the D flip-flops. It's just based upon the memories. So here you can see that there is the output Z, which is 1111 at the end. After using the min terms, or simply you can see that making the graphs that I will show you in the center of this video in the next question. K-mapping techniques can be used to make this, but the simple method is to just make the pick this column, and you can see that only these are working. So by comparing these terms with these terms, you can just say that BC means that here is the only term that is involved is B, and C means that BC will become. This is a long way, but I just this is not my domain, and I have to just show you how the sequential circuit just work. Here I'm not going to apply any type of the input. There is 1 hertz frequency of clock, and after that here you will see that these are the 3 different outputs of these, and we will see how the logic analyzer is analyzing this. And here you will see that the logic analyzer is showing the A1, A2, and A3. These are the 3 terminals that I've connected with these outputs of the 3 latches, and here you can see that the output like this is showing here. This was a question for the first part of the video, and the very next part of the video I will show you how to make a vending machine. This is a simple block diagram of the vending machine, in which there is one only this machine is accepting the coins of nickels and dimes. As you know that 1 nickel is equals to 5 cents and 1 dime is equals to 10 cents. So here you can see that this will be the coin sensor and the vending machine sequential circuit, in which we insert the nickel and dime, and the change and the release candy or bubble gum like that will be the output of these machines. So the melee state machine is like this, in which there are the 3 states. Means that the total number of bits of the state will be 2. So 0, 0, 0, 1 and 1, 0. This is the counting order assignment, in which we use simple the counting order. So this is the state that's going from 1 and then 1, 0. Here you can see that first if I don't insert any nickel and dime, it will remain at its first state. Means that n dash d dash means no nickel and no dime. After inserting the nickel, it will go towards the first state in which the 5 cents are inserted. So after again inserting the nickel, you can see that it is not giving any type of output, but it has gone to the third state, that is 1, 0. And here you will see that if for example the bubble gum is of 15 cents, so after inserting here you can see that I have just inserted 2 nickels. It means that the 10 cents are inserted. So if I insert 1 dime, here you will see that I have inserted one dime, so the output will be 1 and 1, means that one candy with nickel is released as the output. So means that I have just inserted there the um, two nickels and one dimes. 20 means 20 cents we have inserted, and after that it will release one bubble with the means these are the two outputs, the one bubble and one uh, you can say coin that is of 5 cent. So after inserting dime, the this will be the output. And here you can see that direct inserting of dime will go towards the third state without giving any type of output, means you can see that this third state is consisted of 10 cents and the second state is consisted of 5 cents. And after you can see that if I have inserted nickel and then insert the dime into the machine, so the 15 rupees or whatever or cents are completed, so it will go back towards the first state with the release of one gum and no any change. After that you can see that if I don't insert any kind of dime, it will remain at its third state of 10 cents. And after that, if I insert one nickel at the third state, and this completes the 15 cents, and you can say that one bubble gum will be released without any release of coin, means that it is zero. And here is the truth table, state table, sorry, state table for that, in which the present state is the yeah, these are the states 0 0 0 1, and the total number of the state means that here you can see that 0 0 0 1 1 1 1 0, and this is not any state, and you can also neglect this entire table, entire row, or these four columns. This is a state that is not to be used, because these are all as don't cares for us. And when you see that the inputs are 1 1, and the next level states are don't cares, because we don't take the state as 1 1. So here you can also see that, and you can also make the table with the help of the diagram, and it's a little bit long question. And these are the k-maps of this entire table that I have made using this one, and this is the a, b, and d, and after just comparing this table, and I've just made the k-map, and then you can see that this is the equation. These are the equations for this, and you can see that there are total number of a and b inputs, so the two flip-flops will be used, and these equations are as follows. And I'm just these are the k-maps for the input equations. These are the k-maps for the input equations, and here we go, input equations, and now we will go towards the k-map for the output equations, where the y and z are the outputs, and these are the these columns will be used, y and z, for the construction of the k-maps for the output equations that I've already shown you in my previous videos. And this is these are the equations. So let's come towards the construction of the entire circuit. From these equations, I've just made this entire circuit, and here you will see that this is equation 5.5, and here is the circuit that I have implemented using k-maps. There are the total number of two outputs and the two inputs, and we have seen that the two input equations for the D flip-flops were used. And next we will see that after simulating it, we can make it clear that I'm just applying the frequency of 1 Hertz to these flip-flops. And for example, here you can see that I'm not going to apply any type of input, and you can see that the output will be 0, means that there is no. So I'm just inserting one nickel and one dime. So here you can see that the output candy and the change is appearing. Actually it's not clearing, so let me take these type of states, in which means that I have to change the input accordingly in order to just make the output feasible. Actually this frequency is changing with the time, so I have to just change the inputs with respect to time. So you have to just put an eye on here. When it become red, then I will insert one nickel, and then remove this state and convert it into 0. And after again the when the 0 will be appear, I will again insert nickel, and then when this red will be appear, I will insert dime. So you will see the output what will happen next. So here you can see that red, again inserting the nickel. Here you can see that the candy at the output is appearing. So let me see that after the 2 seconds, means that the dime is inserted 2 times. So here you can see that the dime is inserted 2 times, and the 2 output is appearing, because the 2 dimes are equals to 20 cents, and this is giving us the change of 5 cents and the 1 candy. So this output appears after 2 seconds, means that the frequency of 1 hertz is appearing, and it is taking 2 dimes in 2 seconds. So if I remove the dime and just insert the nickel, here you will see that after 3 seconds, means that 3 nickels are inserted, the 1 output candy will be appeared. And after the 4 seconds, will also see that the candy with a change will also be given as the output. So here I've only inserted nickel. So after 3 seconds you can see the output, and after that the machine again refreshes, and again you can see that is giving out. So if I insert the nickel and dime, you will surely see that at the very first second, it is giving us the output of 1, means that the output candy is appearing. But at the very next second, you can see that the dime and the nickel becomes 2, means that 15 into 15, 30 cents, and it is giving us the change as well, and candy. Let's see here. I'm just going to again simulate it. You will see that both the outputs are 1, means that the nickel and dime is inserted at one time. After 2 seconds, both outputs will be 1. So this is the basic idea for this vending machine. Now we will move towards the state diagram of this. So this is the garage door opener, in which here we will I'm just going to make you clear with the help of the original diagram in which I've just made this. Here you can see that this is the initial stage in which you are applying UPL. Actually these are all input: A, DNL and UPL, and MU, MD is the output. So let's explain what are these. UPL is the upper limit, and UPL dash is the inverse of this upper limit, and then A is the active, means that this is the main power switch that is used to on or off the circuit, entire circuit. And then you will see that MU and MD is the moving down state, and MU is the moving up state, DNL is the down limit. And what is the algorithm of this circuit? This circuit will this is not a circuit, this is a state, only a state diagram. So while we apply the upper limit, then you will see that the upper limit button, when we close the upper limit button, then it will go towards the down next state. And then when we just press A active button, so it will move down, and then it will if we let the button pressing for a long time, it will go towards the moving up state. And then you will see that again pressing the A button, it will again go towards the down next state, and then moving down, means that it will move up, move down, move up, move down, until and unless we will unpress this button or open that switch. So after that, here you can see that if I press the down limit button, after moving down, it will go towards the up next state, and then again moving down, means that if it has moved down towards the means that if the garage door has touched the ground, and then you press DNL down limit, it will again move towards the up state, and then pressing A, it will move up. And then you will see that again pressing A, it will again go towards the DN next state, and then moving down state. And then you will see that again pressing A, it will again move towards down, and then move up, and this cycle will be like this. So this is the state table that is given. So from this state diagram, we will make a state table like that. This is the state table that I've made from the diagram, state diagram. This is the simple one, and here you can see that the present state is of 3 bit, because the total number of the state that are making a circle are 5. So the 2 raised to power 3 is equals to 8 is covering the range of 5. So the total number of the 5 states that are most important to us. So here we will go and see that what's happening. So this is the state table I made, and actually here you can see that the total number of the bits are 3. So the 8 cross 8 mapping for the k will be done, and all the other will be considered, all of the boxes that are not the ones will be considered as the don't care for us. And just making and then relating this about equations with this, we have just made the equations like that. Just zoom it and let you know how I've made this. And this is the equation for dB, and this is the equation for DC. And by simply using the min terms technique, you can also calculate mu and md by comparing that with the present level state. Okay, so here you can see that only the three are the ones, so we have just compared it with the present level state. So here is A, and B and C are the 0 zeros, means that B dash C dash. So the mu will be A B dash C dash. So here you can see that. And after that just implemented this circuit on proteus with the help of these equations. So this is the circuit that is used. Actually I'm just applying A, B and C. These are A, B and C are the Q next level state, present level state, that is the here. So I've used the bubble techniques for making this entire circuit by renaming this A, and again renaming the second bubble with A. So here you can see that this will deliver the wireless connections, and I'm applying the frequency of half hertz. So here I've made the circuit like that by using the equations. For multiplication the AND gates are used, and for addition both the AND gates are connected with the OR gates for addition. So these are the A and A dash. Generally I've made this wire and to make the circuit less complex. This is the A and this is the A dash, and B dash, and C dash. And here is the down limit and down limit dash, UPL and UPL dash, up limit active and active dash. This is a simple one. I am just going to apply the 5 volts to the each input, and then again we will use the buttons and just opening all these type of the buttons and A as well. So I am just going to simulate it this circuit. Let's have a simulation, and we will see that the moving up and moving down are connected with the terminals of this servo motor. So here we will see that if I am going to just press the UPL, this is the UPL. So I'm pressing UPL, this UPL button, and now it has gone towards the next state. And now I'm just clicking this active button. So now the circuit is now on. You will see that the motor is first rotating clockwise, and then it will rotate counterclockwise. So this was the state. Here we will see that this is the accomplishment of our state diagram. And when I'm just going to apply the down limit and open the up limit button, you will see that this motor is again moving downwards, means that this is moving the gate downward. So after that, when I am going to apply the UPL button, and you will see that it is now moving upward. So this is the algorithm that is being used in this sequential circuit. And when I just open this button, DNL button now have been opened, and then UPL button has been closed. So if this motor come towards the really extreme position, which you can see that the door is now up, so it will let the door to be closed, means that it is rotating from anti-clockwise to the clockwise direction to close the door or close the garage door. So this is the video for today. I hope that you will really enjoy this circuit. And if there is any query, please don't forget to comment me in the comment section. I will really try to make the things clear to you. So that's the content for today's video. Thank you.